Hello and welcome to my first flipped classroom lesson of the 2016-17 school year. We are going to be starting right off the bat in topic 1-1. We're going to be reviewing a lot of information that you talked about last year in 6th grade and revamping it for this year in 7th. We have quite a few vocabulary words that we're going to be going over. So if you could locate that topic 1 vocabulary sheet that I had you put in your daily notes/handout section, please find that and come back to the video when you're ready. As we're moving along in the video, if there's ever a word that is in bold on your notes, I am going to be asking that it eventually ends up on your topic 1 vocabulary sheet. We will go over that in class today. So let's refresh our memories. I already see 2 words in bold right here, ratio and terms of a ratio. It states that a ratio is a relationship in which for every x units of one quantity, there are y units of another quantity. That sounds like a big definition to me. The easiest way for me to think about it is that if I look at the word fraction, within the word fraction, there is the word ratio. If I just cross off, ignore that C is there, now I have the word ratio. If you think about a ratio as being a fraction, I think this will be very helpful. It really is a comparison of 2 numbers. And I will say right now, our fractions normally don't have units, so our ratios will not have units either. The terms of a ratio are the quantities x and y. Okay, if we say the terms of a contract are what make up a contract, the terms of a ratio, x and y, are what make up the ratio. So they have here this picture here with 2 blue circles and a red square. So I could say to myself that for every 2 circles, I need to have a square. So if I now had 4 circles, how many squares would I need? 2 to keep this equivalent. If I had 3 circles, how many squares would I need? 1, and then a half of a square. Okay? It says that we can use ratios to make comparisons. That's what I told you the definition is, a comparison of 2 numbers. The ratio of a number of circles to the number of squares can be written in 3 ways. 2 to 1 with the word 2, 2 to 1 with the colon, or 2 divided by 1 as a fraction. Now, not to make things very confusing, but I'm going to say that it's y to x. There are the terms of my ratio. Y colon x. There are the terms of my ratio. Y divided by x. Again, there are the terms of my ratio. Example number 1 drops right into this. It's asking us to write the ratio 3 ways. The number of solid colored balls to the number of striped ones. They're saying specifically solid 2 stripes, so we need to follow that order. So I count up, there are 4 solid and 5 stripes. So writing it 3 ways, I could write 4 colon 5, 4 2 5, and 4 divided by 5. B is asking for the number of even to the number of odd. So again, I like to just underline what it is that they're asking me to look for. I'm changing that word to a colon. And so I follow this in order from left to right. I'm looking for even to odd. There are 6 even, 2, 3 odd. 6 colon 3 or 6 divided by 3. Go on to example number 2. Pause the video, give that one a shot. When you're ready, play the video again. Here we are, example number 2. I had 7 that were knocked down, 3 that were up, so 7 to 3, 7 colon 3, 7 divided by 3. We have some more vocabulary on the next page. Now this time we're talking about equivalent ratios. Equivalent ratios are ratios that express the same ratio, hence the word equivalent. Equivalent meaning equal and then same. You can find equivalent ratios by multiplying or dividing each term of the ratio by the same non-zero number. Where I like to think about equivalent ratios is if I had a problem such as 4/5, you don't have to write this down, but if I had 4/5 plus 3/10, If I needed to add these two together, I would not be able to do it in the current form that they're in. I would need to get common denominators, which means I would need to rewrite these ratios with equivalent terms. So I would have to make common denominator would be 10. So I would multiply 5 by 2 to get 10, meaning I'd have to multiply 4 by 2 to also get 10, to now have 8/10. Now I have an equivalent ratio of 4/5 and 8/10. The 8/10 and 3/10 aren't the equivalent ratios. So you can either write ratios, rewrite them by multiplying by a number. So in this case, we multiplied by 2 to the numerator and denominator to get 4/12. So this would be in greater terms. And I would write this down. And then on the other one, when they're dividing by 2, that would be rewriting something in lesser terms. The fractions are equivalent to each other, just being rewritten in different terms. The pictures show you how everything is related, and they're telling us now that 1/3, 2/6, and 4/12 are equivalent. So taking our answers from before, 4 to 5, 6 to 3, 7 divided by 3, can any of these ratios be written as a ratio with greater terms? And you should be saying, absolutely, all 3 of them. Yes, all 3. And you can really use any number that you want to multiply the numerator and denominator by to rewrite them in greater terms. When I have it as 4 to 5, I'm now going to rewrite it as a fraction. If I want to multiply this by 2, I can go ahead and get 2. Now I have 8/10. I could now say 6 to 3. Let's now change it and multiply by 3/3, which will give me 18/9. And that makes sense. This 6/3 is an improper fraction, so 18/9 will also remain an improper fraction. And then 7/3, let's change it up. This time I'll multiply by 4, so I'll get 28/12. All of these are equivalent fractions written in greater terms. Now it goes on to say, can any of these ratios be written as a ratio with lesser terms? And now this one, it's asking you more to write in lowest terms or to reduce. I cannot reduce 4 to 5. I can reduce 6 to 3. I can divide the numerator and denominator by 2, and I'll get 3/1. Nope. What did I do? Hold on a second. Did I make a mistake? Absolutely. I didn't want to divide by 2. There we go, my first error. I want to divide by 3. It's jumping ahead. I do that a lot. I write the answer accidentally with what I'm supposed to be dividing. I'm jumping too quickly, so be careful there. It should be 2 first, or just 2. And I can't reduce 7/3 to a whole number there. Notice that I am dividing or multiplying. It's always by 1. 3/3 is equivalent to 1. 2/2 is equivalent to 1. So it's not changing the value at all. This is actually example number 4. Apologize for that. Given the ratio 12/15, find an equivalent ratio with greater terms and one with lesser terms. On your paper, it's only asking you to do lesser terms. So what we're trying to do is we're looking at 12/15. We're saying, is there a number that goes into both 12 and 15 that they're both divisible by? And it is 3. Side note, the divisibility rule for 3 is that the sum of the numbers adds up to a number that's divisible by 3, the whole thing's divisible by 3. So 1 plus 2 on the side here is equal to 3. 3 is divisible by 3, so I know the whole 12 is. And 15, 1 plus 5 is 6, and 6 is divisible by 3, so I know that the whole thing's going to be divisible by 3. So 12 divided by 3 is now going to give me 4, and 15 divided by 3 is going to give me 5, for a final answer of 4/5. Moving on to some more vocabulary words, we've got proportion, which definitely needs to go on our vocabulary sheet. A proportion is an equation. A lot of students tend to forget this. There is an equation that shows that 2 ratios are equivalent. I have here 2/3 is equivalent to 4/6. I multiplied the numerator and denominator by 2. And over here, x with unknown value, x/5 equals 16/20. And obviously, we're going to go through and figure out what x is equal to. So how we can solve the proportion, and this is already filled in on your paper, is we've got x divided by 5 equals 16/20. We're going to cross multiply. We're going to use cross multiplication. And this is already on your paper where it says to solve a proportion, use cross multiplication. We are going to multiply the 20 and the x. Got a little email there. Then I'm also going to multiply across the 5 and the 16. So 5 times 16, I'm doing that work already, is going to give me 80. So you're going to multiply. And then I've now set up a one-step equation for myself. If you remember equations, I'm going to undo the operation that's happening between the 20 and the x by dividing. We show division with our division bar, and I'm going to divide by the number that is attached to the variable. It's called the coefficient. I divide by 20 on both sides, and I get an answer of 4. So we're going to multiply first, and then we divide. So this is example number 5 for you. We're going to use cross multiplication to solve the following proportions. I will do the first one with you. This is A. I will do A with you first, and then I will have you guys pause the video and do B and C. So again, I'm multiplying across. I can start with the 1 times 12, which will give me 12, and then the 6 times K to give me K. Or, a lot of people like to have their variable on the left. There's absolutely nothing wrong with you saying 6 times K equals 12. Both of these equations are saying the same thing. We need to go ahead and divide both sides by 6. So we will get an answer of 2. Go ahead, do B and C, pause the video, and the answers will be back when you click on it. Okay, so I asked you guys to try B and C on your own, and I got a final answer of 2 2/5 for B. It's okay to get a fraction, or that could be a decimal of 2 4/10 if that's what you had it worked out as. And C, I had y equals 6. Cross multiplying, setting up an equation, and then solving your equation. Right, now on question number 6, we're actually going to be setting up the proportions on our own first, and then solving them. So we're adding an extra step on. So I'm going to show you how I would like it set up with A. I first read the problem, and it says, if 4 bars of soap cost $1.50, how much would 10 bars cost? So I would do cost to bars. That's in words what I'm comparing to each other. Some people might have wanted to do bars to cost, and there's absolutely nothing wrong if you wanted to set it up that way too, if you're reading from left to right. I just always like to put the money on top, the money in the numerator. So now I can set up my proportion, kind of have my blank proportion here. If the cost is $1.50, well, how much was for $1.50? I was able to get 4 bars, so I'll put the 4 in the denominator. How much would 10 bars cost? Means I am looking for the cost, so that is my x, and I would put the 10 bars in the denominator. There are other ways to set up your proportion, and you will still get the correct answer as long as everything is kind of across from each other the same way. We set up our cross multiplication. Some of you like to have your variable on the left, so if you want to start by doing the 4 times x, that is fine. We can go ahead and do $1.50 times 10. When we multiply a number by 10, we end up moving the decimal point 1 place to the right, so I get 15. I divide both sides by 4. We show division with our division bar, and I get 3 7/500, which is $3.75 for 10 bars. That's my final answer, so that's the one that I'm going to circle. Please go on, try B and C on your own, and come back into the video when you're finished. Here we are. Again, for B and C, I've got the words in both to start, so then I don't have to have my labels in my proportions because I have the words to refer back to in the beginning. I got a final answer for B of 3 gallons for 96 miles. I'm labeling my answers as best I can. What I want to point out in C is where it says that the paint will cover 900 square feet. My final answer, instead of writing square feet, I wrote feet squared with an exponent of 2. They mean the exact same thing. So just wanted to point that out. It makes sense that if 2 cans are going to cover 900, if I have three and a little bit with the cans, I obviously have more paint, so I should be able to cover more square footage, so my answer should be larger. Okay? That is going to be the end of our notes for 1-1 right now. Tomorrow we're going to review and go on to finish the notes.